horizontal as shown in the diagram below. The block moves to the east and experiences a frictional force of 45 newtons, right? So guys, it's not labeled on the diagram over here, but it can be seen, or it is stated, that we have a frictional force of 45 newtons. Now, how did I know that the frictional force is acting in this direction, which is left? Quite simply because the block is moving to the east. And if the block moves to the east, by definition, frictional force goes in the opposite direction. So frictional force will have to act in the westerly direction. I like to clear up things like that at the beginning before I actually start with my problem. It benefits me a bit later. It saves me a bit of time. Alright, so 2.1.1, state Newton's second law of motion in words. Guys, I'm taking the definition straight from the exam guidelines, and I'm going to recommend that you guys memorize things, especially definitions, exactly from the exam guidelines. That way you cannot be marked wrong, or when they mark you in the exams, there's no ambiguity. They're going to give you that 2 marks. Right, so it says, when a net force is applied to an object, it accelerates in the direction of the net force. Full stop. Newton 2 always has 2 parts, guys. It's got 2 parts. The second part of this would be the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Right, let us move on. So 2.1.2, draw a labeled free body diagram of all the forces acting on the block. Let's have another look at the diagram. So you guys can see here we have a 125 kilogram block, and we have an applied force going in the easterly direction at 35.9 degrees. So not the easterly direction directly, but at an angle of 35.9 degrees. We have a force of friction occurring in the westerly direction, and then naturally we have gravity going down and then normal force going up. So let's get into this free body diagram really quickly. It's really simple and it's 4 marks. So we have a normal force going up, and I want to urge you guys to always use a ruler for diagrams such as these over here. You want your lines nice and straight. Okay, so we have the normal force going up, we have the force of gravity going down, and then we have an angle force, and this force over here is the applied force, the force applied by the boy. And then because the block is moving in an easterly direction, we have the force of friction occurring in the opposite direction. So we have our normal force going up, our F applied going at 35 degrees to the horizontal, 35.9 if I'm not mistaken, 35.9 in the easterly direction, force of friction going in the westerly direction, and the force of gravity going down. 2.1.3, calculate the magnitude of the vertical component acting on the box. Now, if you guys can remember in previous lessons, the vertical component, otherwise known as Fy, is always going to equal the force itself multiplied by the sine of theta. And the force itself in this circumstance, they want the vertical component Fy acting on the box. That is the vertical component of the applied force. right? But what is the applied force? They gave it to us as 846 newtons. So we are going to say 846 newtons, right? Then we are going to multiply it by sine and then theta over there. But what is theta? Where do we find it? That is the angle at which the force occurs. So we know that the angle is 35,9. We are going to place it over there as 35,9. So we have 846 multiplied by sine 35.9, and we get a force, a horizontal force, apologies, a vertical force of 496,07 newtons. They then ask us calculate the magnitude of the normal force. Well, this one is tricky. Why is that? Let us have a look at all of the vectors occurring within the vertical, and you guys will see why it is not as simple as you might think, because usually we know that the normal is equal to the force of gravity, but that is when we have a block and we have the normal going up and the force of gravity going down. That's when we have a block that's got nothing occurring on it. But in this case, we know that we actually have a block with an angle force going upwards. That means that we have a force, an Fy component that occurs on the box as well. And that factors into calculating the normal force. And I'll show you guys right now how that works. Well, why or how does this work? So we have a block and we have the force of gravity acting downwards on the block, so that's the force of gravity. We have as well the Fy occurring going upwards, but we don't just have the Fy going upwards, we also have the normal force going upwards. So what does that tell me? That tells me that the force of gravity is in actual fact equal to these two components combined. It's equal to the normal force plus the force y, or the vertical force. So if we want to calculate the magnitude of the normal force, we are going to say, well, the normal, and we take the Fy over, is equal to the force of gravity subtracted or minus the horizontal component. Well, what is the force of gravity? Gravity is equal to weight. And what is weight? Weight is equal to mass multiplied by gravity. But what is the mass of the specific block? 125 kilograms. So we are going to go 125 kilograms multiplied by 9,8 meters per second squared and find an answer. And that answer will be 1,225 newtons, right? So we have 1,225 newtons, but from that we are going to subtract the vertical component, and in this case we know what that vertical component is. It's 400, it is 496,07 newtons, right? And that's what my normal is going to be. So my normal is in actual fact equal to 728 newtons, right? Plus minus, the actual answer is 728,93 newtons. So I think that's a better answer. You're going to give it like that, 728,93 newtons. Let's move on. So then it says, calculate the value of the coefficient of friction for the block. How is this done? How can we do this? Well, we have to think about friction. I have done friction with you guys in the previous videos, and we know that for calculating friction, especially kinetic friction. Why kinetic friction? Because we know the block is moving, and once the block moves, we are dealing with kinetic friction, is equal to mu k multiplied by the normal force. Now they say over here, calculate the value of the coefficient of friction. So what value do we actually want? We want this value over here. Now we think to ourselves, do we actually have the kinetic frictional value? Let's look at our diagram. We do. It's 45 newtons. So if we know that we have 45 newtons, we are going to place that 45 newtons over there. We are going to say mu k multiplied by, do we have the normal force? We of course do. So that's going to be 728.93 newtons. Now what we have formed is something known as an equation. For those of you guys that have done grade 8 math, we have an equation. And when we have an equation and we have the subject of the formula, we're going to want to solve for that. So to solve that, we're going to go 728.93. We're going to divide by that. And what we do to one side of an equation, we repeat on the other side as well. 728.93. And then ultimately, we get our mu k equaling 45 divided by 728.93, and we get a mu k value of 0.06. Now mu k has no units, so that will be your final answer. 2.1.6, they want us to calculate the magnitude of the horizontal component acting on the box. Again, the formula is already given to us. F of x is equal to the force itself multiplied by the cos of theta. Well, what is the force itself? If I remember clearly, the force itself is 846. I saw it there, I didn't remember it. 846 cos, I remember the angle, that is 35 degrees. So f of x is equal to 846 cos 35, and you type that into your calculator and you get your answer. And that's going to be 693.002. And we can round that to 693 newtons. Lastly, they say over here, calculate the net force acting on the block. Now they do not mention vertically or horizontally, but what we can do is we can assume that it is in the horizontal direction. And why is that? Because the block does not move up and down. However, the block does move east, and because it's moving east, we know that we have a resultant going in the easterly direction. So the net force of the resultant is pretty much the same thing, F res, F net, and that is equal to F1 plus F2 plus F3, as I've shown you earlier, etc., etc. Now, what are the forces acting in the horizontal direction? Well, if I remember my free body diagram, I know that I have a force of friction acting to the left. And I also know that I have a f of x that I have solved for over here that is acting in an easterly direction. Well, knowing that, I can then therefore say that F net is equal to the force of friction plus the horizontal component of the F applied force, F of x. And once I have that down, I can substitute my values in. But before I do that, I have to choose a direction as positive. And in this case, I'm going to be going east as positive. So with that done, the force of friction is acting to the left, and we know that the force of friction, the value of that is 45 newtons, and because it's acting in the left, we are going to go negative 45 newtons plus the x component we already calculated over here, 693. That's going to be 693 newtons, and my answer for the net force is going to be 648 newtons. Guys, with that we are going to conclude. Please watch out for the next video.